In this video, I'll walk you through a small business network I built in Cisco Packet Tracer. Packet Tracer is a free tool from Cisco that lets you simulate networks without buying physical hardware. You can add routers, switches, and servers, connect them together, and configure them using the same commands you'd use on real devices. For this demo, the goal is to build a complete small business network. We'll separate wired and wireless traffic with VLANs, configure a layer 3 switch for routing, set up NAT on the edge router for internet access, and then verify connectivity to both local and external servers. I began by placing the core devices that make up the network: a router, a switch, a server, an access point, a wired PC, and a wireless laptop. Each one has a clear role. The router connects to the internet, the switch manages communication inside the LAN, the server provides services, and the access point allows wireless devices to join. The PC and laptop act as our clients. After placing the devices, I built the connections between them. The clients, servers, and access points all link to the switch, which connects directly to the router, and then from there, the router reaches out to the ISP. At this point, the physical foundation of the network was complete. With the hardware in place, I moved on to configuring the switch. I created two VLANs, VLAN 10 for wired devices and VLAN 30 for wireless. Each VLAN received its own gateway address with 192.168.10.1 for VLAN 10 and 192.168.30.1 for VLAN 30. I assigned the appropriate ports for each VLAN and added a default route pointing to the router at 192.168.10.254. This allowed the switch to forward any unknown traffic toward the router, ensuring devices could eventually reach the internet. Next, I configured the edge router, which serves as a bridge between the local area network and the internet. On its internal interface, it used 192.168.10.254, while the external interface connected to the ISP with 203.0.113.2. To provide internet access, I enabled NAT following all private addresses on the LAN to share a single public IP. Finally, I set a default route to the ISP at 203.0.113.1. With this in place, the router knew how to forward traffic to the outside world. On the ISP side, I set up a router that connected to our edge router on one side and to an internet server on the other side. Static routes ensure that the responses from the internet could find their way back to the local area network. The internet server was assigned 198.51.100.10 with HTTP enabled, acting as a public website. Inside the local area network, I configured a local web server at 192.168.10.10, and I connected the access point to VLAN 30 so the wireless laptop could join the network. With the infrastructure in place, I moved on to the clients. The wired PC was given an address in the 192.168.10.x range with a gateway of 192.168.10.1. The wireless laptop was configured with the address in the 192.168.30.x range and a gateway of 192.168.30.1. To test the local area network, I started by pinging each VLAN gateway and the local web server. Both clients were able to communicate successfully. To confirm further, I opened a browser and accessed the server's webpage, proving that wired and wireless devices could reach services across the network. We ended up building a small business network in Packet Tracer, creating VLANs for segmentation, configuring routing and NAT for internet access, and verified everything with local and external connectivity tests. This project demonstrates how real-world networking concepts can be designed, configured, and even tested, all through a simulation without having to purchase expensive equipment.